Okay, this is live. What is this?
Hey, everybody, and welcome to another Show and Tell. Happy Valentine's Day. It is Valentine's Day in Show and Tell, and we love all of you and all of your projects that you're going to show off. We're here for the next half an hour showing off your project. We also have Carol, special guest, and we have Snake. We'll talk about that on the show later. But right now, show off your project. Get a couple minutes to get out of here at 7:50 and kick it off with some Adafruit peeps. Let's start with
Nan
Pedro.
Hello, everybody. We have a CircuitPython project this week, and this is it right here. It's a big button. This is our massive arcade button, and inside the button we embedded the Circuit Playground. So this project, you can press the button, and whoop, I didn't turn it on yet. Let me turn it on. So we got I like this potentiometer because there's a built-in switch, so you can turn that on, give it some volume. Let's see, is it working?
All systems are fully operational.
Awesome. So this is running CircuitPython. And that means you can take this to a Windows machine or a Mac machine. You can edit the code. The library's in here. It's amazing. This is portable Python. So this project the goal of it was to really replicate the big Mac button. Yeah, I forgot to turn it on too.
Yeah, we go.
Those electrons are amazing.
Those electrons sure are amazing. So it's really nice and expandable. It also has like a secret feature where you can plug it into a computer and it'll act as a USB mouse. So you can do some cool stuff with that. It's a bit of a starting point because I think you can do a lot of different things. It does have Circuit Playground. You could use maybe the accelerometer to like move the mouse or something or change different colors. So it's a lot of fun putting it together, and hopefully the AT community will kind of reuse this project.
All systems are fully operational.
It's perfect.
This is awesome.
Yeah,
It's an inspiration from Bill Binko, who
Bill Binko, shout out to atmakers.org. Check them out on Facebook. There you go. That's my spiel.
Sneaky
All right.
Facebook.
Okay.
All right, guys.
Next up, Tony D. Tony D, what you guys this week?
Hey, yeah, so I have an update on the Sinobit, and this is Sinobit MicroPython. So I've been porting MicroPython to run on the Sinobit. And of course, it runs the digital sand demo. So I ported it over. Phil B originally wrote this, and then Dave Astil's converted to Python code. And so because the Sinobit has an accelerometer, it can detect orientation, but it's got the larger grid of 12 by 12 LEDs. So you can show more pixels, more grains of sand on here. So it's really cool, and it runs really well. So it's kind of exciting and interesting to check out. I'm having a lot of fun with the Sinobit. And I'm hoping that the next thing will be getting Chinese text rendering on the Sinobit. So I've been digging deeply into that, and it's interesting. So it's a really cool language. A bit of a shock, though, to me, to realize there are 22,000 characters in the entire alphabet. And just doing the math on that, to store just the bitmaps for the 12 by 12 characters would take over 300 kilobytes, which is a problem because there's only 256 kilobytes of memory on this board. So I'm going to have some fun. Luckily, there are smaller subsets. There's about 5,000 characters. That's the standard for most communications in China. And maybe you can get away with 3,000 or so. But any guesses what the first Chinese text I hope to scroll across here will be?
Any guesses? I would say electric because it looks like a little snake or something like that. Because it looks like
that's a good one. I'll have to look what that is. But
it's a box with a snake coming out of it.
Yeah. So I'm hoping to get Gong Ti Sha, which I think I'm pronouncing correctly, which is, of course, Iron Man in Chinese. So
Okay.
that's what we'll have to do.
That's
We'll
my second guess.
Yeah, it's going to be a challenge, but it'll be actually pretty fun because learning a lot about Unicode and character encodings and how all of that works. Because, as an American Westerner, we just deal with 26 characters, so we don't really realize how difficult things can be when you add a lot more. So,
actually, I think the Chinese symbol for computer is when you look at is a pictogram? Is it the right term? It's electric brain or electronic brain.
Cool. Yeah. So hopefully I'll get that scrolling across here in the next few weeks or so. We'll see what we can do with it. So,
all right. Thank you so much, Tony D. All right. Next up, Phil B.
Hello there. Speaking of sand, a couple weeks ago, I showed the demo working on the big LED matrix, and I promised code for it, which I forgot to put up on GitHub. So it's there now in the Adafruit Pixel Dust repository. And this is running on some new hardware that's just in the shop now, 64 by 64 LED matrix, and the RGB matrix bonnet, which is stuck on a Pi 3 here. But the demo, it actually works perfectly well on even a Pi 0. So those are available now, and maybe I'll do a guide even for how to put this stuff together.
That's cool.
That's very fun.
Yeah, it's very, there's something very tactile about it. Also, there was this word I was searching for a few weeks ago and I couldn't remember it. It was emergent behavior, which is when you have a very simple set of rules and a complex behavior comes out of it. And that's the thing, is that the algorithm for the sand here, like, shouldn't work. It's too simple. But when you repeat it in large numbers, it looks like something fairly convincing. So that was my jargon term I was searching for, was emergent behavior.
I think Stephen Wolfram in his next follow-up to New Kind of Science, that could be the cover of the book, because it's what the book was based on. It's like the universe is just this little math puzzle. It's like it's building on itself. Yep. All right, good work, Phil.
Yeah, these matrices would be really good for a gigantic Game of Life. I'm not a huge Game of Life fan, but it would look pretty cool on the 64.
Just when you get a lot of pixels in one place, there's just something very viscerally appealing.
I like that some get stuck until you tilt it. That's kind of nice.
Yeah, they get wedged if there's a corner between two pixels. They'll.
Yeah, because it's like even though it looks, I mean, it counts as a square. Like
yeah, that's cool.
It's rounded, but it's not actually rounded.
Right.
You can get stuck in the pixels.
All right.
Flatland.
Next, Erin. Hello, Erin. How are you?
I'm good. I am here to show off the new project. I know it's Valentine's Day, but this is kind of an Easterish project. I made a set of bunny ears. It's got a circuit playground inside, and I'm using the MakeCode interface to code it. So just dragging and dropping blocks of code, and it does some fun stuff. It'll I'm using the tilt sensor so that when you tilt your head, the ears will actually react to the way you're tilting and do a cute little animation there. And then, of course, I put a bunny hop one in there, too. So when you hop up and down, there's another animation that comes out. So these are pretty fun. Just kind of silly project. But it's pretty fun using MakeCode. It's a lot of fun to just drag and drop and see what you can get things to do. So I'm having a blast with that. I'm working on a tutorial for this, and the guide should be out probably sometime this week.
Okay, cool.
Good stuff.
Yay, bunny.
All right. JP.
Oh, can't hear you, JP. No.
It's going to be maker charades for JP. 2 syllable, 1 syllable.
1 syllable.
That was my signal for hold on.
Okay.
It was more fun to pretend.
All right, what you got going on?
So I just published a guide on making a secret hollowed out book, and I worked on that last week on my live stream. So here's an example of a book that's been hollowed out, sort of traditional technique for this, which is using Mod Podge or glue around the edges, leaving some loose at the front, and then cutting for a little while. I also demonstrated doing that with an oscillating saw, like a Dremel saw, and then gluing that inside. And in this case, I've got a secret USB key with some very important information on it. And then I also did, in the guide, a couple of different alarms using Circuit Playground Express. So this one is actually kind of a intruder detection one. So you know that old trick of putting a hair across the door frame to tell if someone's actually gone in somewhere or not. This is like that. So this has a secret code that you punch in to arm it, and it gives you a couple seconds, and now the light sensor is activated and it's waiting for a bright light to come on. So when it's opened, this blue says, this is the first time this has been tripped. So if I go back and look at the book and I see blue, I know no one has done it before. Then it turns steady yellow. So anytime after that, if we see it yellow, that means someone's been there. And if the person who has been there tries to cycle it, they're going to get red LEDs. So we know that happened. So there's no way that they're going to be able to fool you. So kind of a fun educational one. I don't know that I would store state secrets with this alarm, but it's kind of a fun one. But speaking of state secrets,
it's better than what's currently working. So I'm gonna say.
Along those lines, I also have a page in the guide about using Haven and an old burner Android phone, which is an application written by the Freedom of the Press Foundation, another group. Edward Snowden was involved, Michael Lee. And this is a really interesting application that uses all the sensors on the phone, so camera, motion, sound, maybe one other, light detection, not just motion detection, to alert you when someone's snooping around physically with your stuff. And it can be set up to log the information as well as to send you an end-to-end encrypted message over Signal or to SMS you. And so I show in the guide how to use that for the same sort of thing. It could be a room detection for sound, or if someone opens it up, you're going to get a nice picture of their face sent to you.
Yeah.
Okay. Well, thank you for keeping all of our bookshelves and nation safe.
Yes, please. And next live stream tomorrow I have 4 o'clock Eastern time. I'm going to be diving into some locks and lock picking demonstrations and explanations. So this is a demo lock interior cutaway that I built a little while ago that I'm going to use, as well as another demo to get people started on some lock picking stuff. So that should be a lot of fun. Please tune in.
Very cool. All right.
Nice
Thanks,
model.
JP. Okay. Next up, we're going to go to Coding Pro. Hello, Coding Pro. Welcome
Hey,
back.
welcome back.
Hello. So I've been playing around with a Raspberry Pi, and if I can share my screen, I have a VNC viewer window, and I have this Python program running. So when I press the button on this thing I made, I'll show you it after, I can take a picture. And you won't see anything on the screen except for a file.
You take a picture, and then it'll probably just be like, boop, there's a new picture in the folder.
And then let's see.
So I have a file here. The picture goes here. And then I can show you the thing. Here it is. It's Minecraft theme.
Oh, cool.
Oh, that's a good idea.
I love it. It's a
So
selfie bot.
It's a Minecraft camera.
It's a selfie cube.
There's a Pi camera in there and a button on the back. And on the inside, there's the Pi cable here. There's the Pi. Yeah.
Nice.
So, yeah, you could use this if you have like a Minecraft theme party. You could like bring this and then take pictures. I was trying to get it to upload to Dropbox, like one of the Pi cameras did, but I couldn't do that through Python because it looked really complicated to run other operating systems. This was meant to be a guide on Instructables, but I don't know if I'm going to be able to get time to do that. But
Okay.
so
Great work. Just plenty of room on the inside or out for an SE on the show and tell sticker, email, support@adafruit.com. We'll send you out one. All right.
cool.
Next,
Thank you.
JMK, how are you?
Hey, JMK.
What you working on
Hi.
this week?
So, first, this is something like one of my friends gave to me at school today. So it's Valentine's Day. Of course it is. So, there's just a little heart wristband. And then I opened it up and I saw this circuit. And first I thought, well, where's the chip? It just looks like it flashes these LEDs really fast.
Yeah, where's the chip?
And I was like, where's the chip? And if you look closely, if you take the button off, you can see there's a white epoxy blob. White.
Yeah.
Yeah.
So yeah, there it is.
That's it.
Yeah, pretty boring. And then next, let me just get sharing window to work. So let us share this window.
Okay.
QoS. So hold on, let me launch it. Oops, and full screen that. The default credentials, and then it's JamCos 128.2.
Yay!
congrats.
Yay! Jam Chaos.
So it's not on the website yet. It'll be up very soon. And there's a new command called edit. Wait, oops. Edit. There we go. So it all it's going to do is right now it just is going to just replace all the contents of a file. Like I can do edit -w. Oops. There's a slash there. Whoa, what's going on? Edit -w. Then I'll type test.txt. Then I'll just create, it'll say hello. Now there's a file called test.txt which was already there, and then now it says hello. So that's just a simple program there, and you'll be able to, and if we go to, there's like edit-f, and that just does the Python pass command, like that, and it basically just means it doesn't do nothing, and that would be used if you have to like reference it from something else. So there's that command, and then last, let us stop the screen share. I got the Pocket Operator. It's
Cool.
in its case right now, and this is I make one of the patterns, and I edited. So yeah, there's that, and then so that's cool, and you can I can hold the record, and then I can add a sound. Now that's part of the pattern. So yeah, that's one thing, and then so that's pretty much it.
You're doing a lot.
Okay, good work, JMK. If you want us to post about the latest JMKOS, drop me a note and I'll post it up on the blog.
Yeah, sure. I also I found the Discord post in the blog blog section of the Discord where it said that you posted it. So yeah, I found that.
Okay. Good work.
Good work. Reverse engineering, text editing with a standard text editor.
All right.
And
next
Python
up.
too.
Yeah, Python too.
You got it all going on.
All right, Rebecca. Hello, Rebecca. How are you?
Hi.
Hey,
What's
hello
going on?
again.
So this semester I'm in a class about paper making. I've actually been making paper out of other paper and also jeans. So this is made out of denim. And this actually has some wood pulp or wood shavings embedded in it. And I was thinking, like, why not embed neopixels inside paper?
Right.
So I haven't done that yet. I'm going to do that tomorrow, but I have some of the Flora neopixels, and I was thinking with some of conductive thread that I could put it in the pulp while it's still wet. And then when it goes to, after it dries, I'll actually be able to hook it up to a circuit. And I have a Gemma M0 that I haven't played with yet because I just haven't found projects to do with it. So I was thinking maybe a Gemma M0 powered paper with LEDs in it. And I looked it up online to try to see if other people were doing this, and I found an old Instructable with like regular breadboard LEDs from 7 years ago, and that seems a little boring, so neopixels.
That sounds cool.
Upgrade time.
Yeah.
Cool, electronic paper making. All right.
Yes.
Good stuff. Well, if you want a sticker, I'll send you out one.
Okay.
You can stick it on your paper.
All right.
There you
Next, Zach. Hello, Zach. How are you?
Hey, Zach.
Hello, I'm doing pretty well.
What you got going on?
All right. So first of all, last time I was on here, what I showed off was a project called the Fur Box, and I never got to show the completion of that, so I wanted to show a quick video of that first. I couldn't get the audio to come through, but really it's just the servos in the box you hear. So.
Oh.
Hello.
Hey.
Hi. Time to go back to sleep.
The silliest take on the useless box I could have possibly come up with.
Yeah.
But it's
cute.
way cuter.
All right, but that's the side project. The main project I wanted to show is that I'm making progress on my costume, and I have the tail to show off right now. Let me turn off my lights here so you can see this a bit better. There we go.
That's great.
That's a nice tail.
Awesome.
And this is just a temporary covering, which means I can show you what all we have here.
Oh my goodness.
Oh,
Yeah.
and what I have is a failure in my tail. I did not even know about that. This entire structure is 3D printed, designed and printed it myself. I have just over 150 neopixels on this one. And then it's got this, what I call the power burrito at the top here. This doesn't run just the tail. This is going to run the entire costume, which this here is a really cheap cardboard box. This is an entire box of neopixel that just came in today.
Yeah.
When the costume is all said and done, it's going to have roughly 4,000 pixels on it, pulling a peak of about 80 amps. So this battery pack can run it for 6 minutes. But this is a good proof of concept on the system. It's using a modified version of the OPC controller, the one to create video for dot stars. And I modified it to work with the Octo WS. So the entire thing is going to be 25 FPS light suit that was really inspired by Blue Man Group that I should hopefully be able to perform in. So hopefully in a couple of weeks I'll have some more to show on that. The next thing up is to work on the mask, which is going to have cameras in it and video displays, the ones that Philip did the tutorial for as well.
Outstanding. Well, keep coming back. If you want a sticker before then, that's fine, but you can also save it for later.
This is so intense.
Nice
I
work,
almost
Zach.
forgot. I had one more part to show off here. Let me get this up. This is a demo of the light engine running. So again, I've got the actual video source showing in the corner and playing at full speed then on the light array. Eventually I'll have the entire light array over the entire suit. So all I have to do to make any light pattern I want is record a video of it and then export it to the suit.
Yeah.
Like there's little cats inside of the video.
There's cats in the video.
It's cats all the way down.
On the fur.
Well, it's a wolf costume, so I had to go with something with ears and a tail.
Yeah.
Okay.
All right, Zach. Outstanding work.
Nice.
Okay, we're going to go to Matt and then to Adam. We should have enough time. All right, Matt.
Hey, I gave my smart airsoft gun an upgrade.
Right.
See over here, I have a GPS feed right now of my location. If you push the button on the rotary encoder, it will take a picture and send a text message with my location and a Google Maps link along with the picture to anyone I program in ahead of time. And I just wanted to show you guys the this is the dark side of the room, so if I do the night vision, you can see it.
Oh, yeah.
Cool.
So this is a map, and that's not my real location, but it
Right.
shows. And then this is what a text message would look like.
Oh, that's cool.
Yeah, that's cool. That's rad.
Good work, Matt.
Thanks.
All right. And last up, Adam, play us out. What you got going on today?
Yeah. So I've got a bit of a hybrid SCM Valentine's Day project. I've got my sputter coder here, loaded up with something a little bit odd, but we're going to get this going first. It's going to take at least a minute to sputter code. So I'm going to say what I'm doing and explain how it works afterwards, just so we can go a bit faster. I'm going to turn my high voltage on, turn my voltage up to 1.4 kV, and then I'm going to start leaking some argon gas until I get to 10 milliamps. Once I get to 10 milliamps and I get it stabilized, I'm going to go to my timer and I'm going to start it. Okay, so now we've got a minute to talk. So what's going on in here is I've flooded a partial vacuum with argon gas, and then I've applied a high voltage to the argon gas, thus ionizing it. And I've got all these argon ions flying around and actually knocking gold particles off of a target and depositing those gold particles onto my sample. So this gives me the capability to coat things in gold, which for electron microscopy is really important because you have to make your samples conductive. So the best way to do that is to use gold. So you can see I've got some previously gold-plated samples in here. And this particular sample isn't something for electron microscopy. It's actually something for Valentine's Day. So I'm going to go ahead and share screens real quick and show you what I've been up to. So I got this idea about an hour and a half before show and tell started, so it was pretty rushed. I went outside, grabbed the angle grinder and bench grinder, cut out a piece of stainless steel, or just steel actually, polished it up to a nice finish, and then put duct tape over it. Once I got that duct tape over it, took a drawing of a heart and cut the heart out of the stainless, and you can see, or out of the duct tape, and now I've got a duct tape mask. And so I've put this whole device, or put this whole setup inside the sputter coder, and now we have got another, it's not quite gold colored, so we need to go a bit longer on it. But
okay,
we have got, in theory, a gold-plated, or a golden heart on a piece of stainless steel. I can just lower my electrode. There we go.
It's so handy to have a sputter coder in the house.
Yeah.
I know, just be able to casually play stuff with gold. Great. We're going to go ahead and accelerate the return of the current up. So I just dropped the head closer to actually get the gold to stick. So that's working. I'm going to turn the lights off real quick so you can see the plasma, because the plasma is really cool. So I'll be right back.
Yeah. It's the only live gold plating.
Okay, so let's see here. Turn my exposure up. And I'm just going to go handheld for this. This is probably a bad idea, but we'll see how it turns out. So you can see the plasma in there.
That's
so that is a cloud of gold right there, which is something pretty you don't get to do every day.
That's rad.
Anyways, let's see if. What'd you say, Phil?
Where'd you get the gold from? Like, how does that? Is it like a solution, or do you just get pure gold chunks? How do you get?
I got to turn the lights back on. I'll be right back.
Okay, later.
He's getting more gold.
Sorry, I couldn't see anything. So the gold comes as this. It's a circle of gold. It's a pretty thick sheet. This is an old sputter coater, so they put way more gold in these things. This thing was actually okay. It looks like we got a gold coating now. This thing was actually made by the manufacturer of my original electron microscope, ISI. So this thing's been around for quite a while. Anyways, I'm going to shut the system down real quick. Actually show you the gold target inside. So I just need to turn all of the different systems off. Okay, that's off. My gas flow's off, and we are good to vent air into it.
Gold is best.
Gold is best.
Gold is best.
Yeah. So we actually use a very, very minute amount of gold to do this. It's pretty impressive. So that's my gold target up there. This is the sputtering head. It's really specifically shaped so that it forms the plasma into a specific cloud and directs where the gold goes. And I realize that I'm gloves, so I'm just going to use a chem wipe to pick this up.
Yeah, that's fine.
And you
Safety
can see,
first.
Oh, look at that.
Oh, that's not for safety. I just take my fingerprints off it. We've got a gold-plated little Valentine's Day present. So I'll take the tape off, and we'll be left with a pretty cool contrast of gold on steel. Put a coat of varnish over it, and have something to give to somebody. So, or I could put in the SEM.
Yeah. All right. Well, great work, and congrats on a very complicated, interesting live demo.
Yeah, that's cool.
I'm pretty happy it worked out. So.
All right.
Sweet. Nice sputtering.
Well, thank you so much, everybody. Thank you, Rebecca, Noah, Pedro, Matt, JMK, and everyone else on the show and tell. We're here every single week. Thank you for making not only this the best Valentine's Day, but the best Wednesday every single week, half an hour where you share your projects with everyone and make the world a better place.
Python, paper making, gold sputtering, airsoft.
If I could coat you all in gold, I would. Okay.
Everything.
All right. We'll see everybody on Ask an Engineer in a couple of minutes and see you next week.
Thank you, everybody.
Bye, everybody.